So this afternoon, we have a special guest, Dr. Hilary Stockdon. She's currently the science advisor for the USGS US Geological Survey Coastal Marine Hazards and Resources Program. In previous roles inside and outside of USGS, her focus has been on leading the development and coordination of national programs for coastal research and science applications aimed at addressing stakeholder needs. Earlier research on the impacts of storms on coastal communities has led to tools that predict beach response to extreme events and raise public awareness about the value of scientific information on coastal vulnerability, helping residents prepare for challenges associated with living by the ocean. She received her bachelor's in geology from Duke University and her master's and PhD in oceanography from Oregon State. So please join me in welcoming Hilary.
Thank you so much for having me here today. I haven't given a talk like this since before COVID in front of people, so thank you for the opportunity. That was I didn't really listen to what you said about me, and I know I wrote it, so, but I'm gonna maybe say it a tiny bit more. Yeah, I've been at the USGS for about 25 years now, and the first 20 or so were really dedicated towards research of what waves and currents do to beaches, particularly during storms. We can understand what's going on and model it. Can we forecast what's going to happen in the next week and maybe into decades? Over the last 5 years or so, I moved into building the Coastal Change Hazards program at USGS, so working across the whole bureau about what the science that's done at USGS can do to really help the public and people who have to make critical decisions along the coastline. Also in that, so I work internal in USGS, but also externally working with other federal agencies to really help navigate that busy space where a lot of organizations have missions related to the coastline, but very unique roles that are dependent on each other and sometimes overlap and seem confusing. So, part of my role has been to really help define what the USGS role is, and particularly when up against NOAA, because everybody says NOAA does the coastline. Well, the USGS part of that is really where the waves and the tides meet the land, where people live, where the resources are, where anyway, the little critters are, and that's where we are. Okay, so here's an outline for today, how this talk is going to go. I'm first going to talk a little bit about the motivation for doing this work, of focusing on the coastal science related to hazards and risk and resilience. Then a little bit about the USGS Coastal Marine Hazards and Resources Program. Then I'll spend some time going through some of the work across USGS related to modeling coastal landscape change. Dig a bit more into how that relates to people, risk and resilience, and then we can have some time for discussion. Okay, so that's a picture that's been hiding in the background of my slides. That's the coast of New Jersey after Hurricane Sandy. I was working on a science project where we would forecast, predict what might happen to a coastline when a hurricane made landfall. And so this was simply combining getting the total water level elevation, which is tides, surge, and waves, comparing it to the elevation of the beach to decide if there might be dune erosion, if sand might get transported and moved across the beach and the road, or if the whole area might go underwater. You can see from the devastation here in New Jersey, these storms are a really consequential problem for coastal communities and resources. I don't need to tell you that, but my work was going into places like this to understand what had happened. It was more after the fact. Okay, so my little piece of this in late October 2012 was creating that model. On the left over there, those red stripes indicate what might happen when Hurricane Sandy made landfall in New Jersey, New York area. The red means bad, so it looked really bad. We were predicting that the dunes would likely be eroded by this storm. With my colleagues there, Peter, were you there? I don't remember, 2012, but
I stayed behind.
we ran our model and we put it up online for everybody to use and benefit from. And then I left the office and went to my daughter's gymnastics meet in Tampa, which is across the bay. I'm in St. Petersburg, Florida. And that's my daughter. And I was sitting there watching what was going on, halfway interested, and my phone rang. It kept ringing. I was ignoring it. But I finally answered it. It was a firefighter in New York. And he said, hey, I got an emergency. I'm hoping you could help me. And this had never happened to me before as a scientist. Right? I'm running the models and then learning something and then doing it again. He said, I saw the forecast where you predicted that the dunes were going to leave. He was on the Rockaways, that the dunes would be eroded. And that happened. And so that top picture is where he was, with the dune on the right. And he said, now, after Sandy, this picture here, the dune is gone. And there's another storm. Y'all probably don't remember this, but there was another storm offshore after Sandy making its way, like a week or 10 days later. He said, another storm's coming, and I'm really nervous. What's gonna happen? Do you have that same forecast for today's conditions for this little storm? And we had nothing. I had nothing to tell this man, and he really was just needed information. Where can I get something? Well, we didn't have any updates. We hadn't collected any data to revise the models. Plus, we weren't built. We didn't have a system to deliver the information. Like, people needed it, in a format where they could get it on their computer and mash it up with whatever other information they had. I mean, at the end, all I could say was call NOAA, which is something no USGS person should ever say, but I did. I said, call NOAA, and that was that. But it ended up being a major motivator for how USGS started to change its view of the information, the scientific information that we provide. It needed to be available to people because the USGS is the earth science, the federal entity responsible for earth science research. And a lot of that work was put out in journals in advancing the understanding of earth science processes. Also, we're public servants and we're funded by the taxpayers, and we better put some information out there that people can use. So we had really fantastic science that could help people make smarter decisions on the coastline. However, it wasn't accessible to them in a way that they could use it or that they understood. My Hurricane Sandy experience up in New York was happening all over the United States. These are some examples from all over where we're seeing storms impacting barrier islands, El Nino events on California, causing the collapse of coastal cliffs, permafrost loss in Alaska, and then the South Carolina image there is this king tides or sunny day flooding. So people are living in coastal environments where really crazy things are happening. We've got storms combined with sea level rise and consequential decisions related to how people are gonna be prepared for emergencies or live in the plan for decades out. They need information, they're making decisions without it, and so it's really our responsibility to get them that information. So this is what is motivating the USGS Coastal Marine Hazards, what's that program name? Coastal Marine Hazards and Resources Program. The coastal change hazards component of that is targeted towards delivering this actionable science to people who need it so that they can anticipate, adapt to, and mitigate for coastal change hazards. So that's the land moving out from underneath of them and building coastal resilience. A big part of this as a research organization is that we connect with stakeholders to understand what their needs are. We address the science related to that, and then we move on to the next science question. Ultimately, we need to show that the science we're doing is really helping guide investments along the coastlines, the management strategies for resources or policy choices, ultimately reducing economic and ecological losses and improving safety. This is the way that we're thinking about science now at the USGS. And I want to pause for a moment because visiting a university and hearing everything that you all were doing was really amazing to me. And I loved getting into the details. And I thought this talk is going to be so incredibly boring because it's so big picture. And it reminded me though, of just even the mindset change that I went through coming from graduate school and university and focusing on really interesting aspects of some science process to needing to work across all environments, understanding what's happening in permafrost coastlines and the marshes and barrier islands and rocky coasts. So that's really what my job is to be able to advance direct science towards all of those environments, all the different people who live along US coastlines and the different challenges that they have. And to do this, it really starts with partner engagement, working from the beginning with the people who need information to make decisions about how they live. They're making investments and they need to know how to make smart investments. This may sound obvious, and in some ways it's good that it's feeling that way, but for quite a while the USGS was not motivated by that. We were very proud of being a science organization committed to fundamental research. However, as I said before, that research has to serve a greater purpose. So based on that engagement of what people need and how they need it, we use that to guide the research, the physical understanding of those processes that are confronting them, and also in the product development. Social science is a real important part of that, data visualization, user testing. So the recognition that in the business of science and providing this information, there are a lot of different roles beyond scientific researcher, but what are we trying to do? So USGS coastal program is congressionally appropriated dollars to address problems like this. We've got 3 science centers who are directing research and working with people to answer questions of like, where is the water going? So some big storm is happening offshore. Where's the water gonna go? When's it gonna get there? How high will it be? How long is it gonna be there? Is the beach gonna change? Is it gonna be messy? Will the beach come back by itself, or will we have to help it? Is it gonna get worse? How bad will it be? It's these simple questions, reframing the way that you're thinking about the scientific research you do in these simple terms of the questions people are asking. So thinking about USGS science, scientific investigations, and how to provide answers to those questions. We want to combine observations, oceanographic observations and observations of coastal elevations and land cover in models of processes about how the two interact and feedbacks between the two to understand what happens when big waves, big surge interact with the landscape and cause significant changes that impact communities. So taking that scientific research, creating tools, that's the thing here, that takes the scientific understanding that we have and provides it in a form that answers the questions like I showed you before. Where will that water be? How high will it be? And then this important piece that is newer for us and something we're really still learning to do is then that cycling back from after providing this information to its stakeholders, learning from them again, what didn't work, what does work, what is frustrating and annoying, where are the science gaps by evaluating the models and going back and doing it all over again. And so this scientific research to operations and applications is something that USGS is thinking about as we consider our role in the federal government of research that answers people's needs. However, we can't sustainably provide that because we are not funded to do that. So this is a question that we're struggling with right now. So getting into a little bit about more details of those, the research and the products or tools that come out of it. Really, so this administration has priorities related to coastal hazards, risk, resilience, and really wants to see products coming out that people can use to make their lives a little bit easier. Coastal storms right now are the stress test for coastal resilience. They are, those large waves, winds, the rainfall associated with it are showing us the impacts here. This is Florida, it's a hurricane in Florida, of what we might see in the future. We're seeing it now. USGS works with NOAA to combine their model of their oceanographic inputs, waves, tides, surge, with USGS models of wave run-up and likely coastal change on beaches, so whether it might, the beach might erode or overwash, to give people guidance about what might happen when a storm makes landfall. So this figure, this map with the blue, this is an image from Hurricane Ian, which was last September, coming towards where I live. And the figure shows the likelihood of dune erosion or overwash. There's that sand pushing up on the beach and into the roads, or inundation, which is when the whole beach system just goes underwater. And red means it's about a high likelihood of that, and in fact, that is what we observed. This information goes out 3 days in advance of landfall. It is updated along with the National Hurricane Center's improved forecasts of the oceanography, and it is used by our federal partners to help guide their preparations and response after the storm. However, it's not just the hurricanes that really are the problem along our coastlines. There are places along our coasts that get flooded just with big waves that happen to come with the wind from the right direction and a high tide. For example, this picture from the Outer Banks in North Carolina from September of 2021, it closed Highway 12, which is the single road that goes down to the southern towns. This happens pretty frequently in this area, and it just causes a big mess for the residents who live there. This blocked the transportation to this towns to the south for a few days. They had no warning that it was coming. So USGS and NOAA have worked together to implement that same type of model that I showed you before for landfalling hurricanes. But this time the model runs continuously. So it's a 7-day hourly forecast of the total water levels that's shown in this figure here. It's the tides, surge, and waves. You can see that higher bump there is associated with that unnamed storms that came in. And it's the wave component here that adds the additional information beyond that which NOAA provides alone. So this came from research at the USGS that's understanding that waves really can double the elevation of water levels at the coastline. combined with the operational capacity of NOAA to really implement the model and then provide it nationally. So this total water level viewer on the left is used by emergency management personnel to help them prepare for events such as this. You know, the ones where the Weather Channel is not going to go out and be excited about it, but your community really cares. This model is now operational in all the Gulf, and Atlantic coasts, and in its development phases, or for Alaska and the California, Oregon, Washington coastlines. You can see the resolution there is to support local decision-making, and it was developed in coordination with local weather forecasters to meet their needs and help them answer the questions coming from the people in their community. I want to emphasize again that this is national, that is a federal program. We have a responsibility to give people across the United States an understanding of what these coastal change hazards are. It doesn't mean doing the exact same thing everywhere, but it means working to provide information that can inform decisions that are somehow rooted in understanding erosion or flooding where you may live. So one first step at this was just to understand past changes to our shorelines simply by measuring where the shoreline has been over 150 years. This is just simply done with analysis of T-sheets or old aerial photographs or LiDAR data. And then working with that data and on into the future using satellite data to understand the probabilities of future shoreline change. And so this is based on data assimilation, using the satellite imagery for updating, and also some understanding of what the expected sea level rise rates are in the area. So a more process-based modeling also is occurring. It's being done at USGS, this hydrodynamic modeling of waves and water levels for future conditions. So in this example, this is the Cosmos model that has come out of the Santa Cruz office, where they're looking at future storm scenarios and sea level rise to understand how high the water is going to get, what the impacts to groundwater will be, how the shoreline will change, and then comparing those results to socioeconomic data to really understand the impacts to people, infrastructure, communities, and define the locations where people, or both the local planners and managers, really need to focus their attention. There are some scientists who are working directly. I'm just start noticing that video is playing, and that's good. So the video over there is an integrated morphologic modeling with changes in sea level rise and storms. To look at Dolphin Island there, which is in Alabama, an island that has been devastated by several hurricanes. And the barrier islands in this area are really important for tourism, but also for biodiversity. They provide storm protection, and there are a lot of state and local groups working to restore those islands. However, they need some information to base those decisions on what islands they want to restore or the methods or approaches they want to use. So USGS is working with those local groups and state groups to support structured decision-making by providing this integrated multidisciplinary modeling to help them understand what might happen to barrier islands in storms during higher sea level rises. Really, I do appreciate you coming in like that so I can catch my breath. I was saying I haven't talked so long in one swoop for a long time. All right, so I'm talking about USGS and coastal change hazards and risks and the models that we are creating to provide the public with scientific information that can inform decisions they have to make about living on a place where waves and currents and storms move the land where you're living, and sometimes in scary ways. All right. So the modeling that we're doing is focused on observations looking to the past, using remote sensing to help us take those models into the future using data assimilation. We have models that are addressing the event scale, so storms that might happen this week, and also these scenario-based models that are geared towards planning in the future for decadal scales, so that we can help to explain what the coastline will do in future climates. So the scientists that we support really are focused mostly on physical processes of that nearshore oceanography and coastal geology, how those two work together. We also want to understand, though, how those physical processes are impacting things that people care about. So not just communities and infrastructure, but marshes and coral reefs, any of the natural resources. So we're working more closely with ecologists and social scientists to combine these, the knowledge of these fields. Thinking about the coastline, it also provides a lot of nature-based protections from storms now and into the future. For example, coral reefs. That figure on the left, I believe that's Hawaii. The coral reefs they dissipate wave energy as it's approaching the coastline, as do wetlands, sand dunes, seagrass, and really protect the communities from the impacts of large waves. USGS has been quantifying on coral reefs the amount of protection coral reefs offer. With the loss of coral reefs, how that translates to dollars and damage to people's communities, potential lives lost, and thus the value of restoring coastal reefs. So the scientific research we have there gets fed into NOAA and the Park Service and other groups who are working on reef restoration to help them target where to better put their efforts there. That was fast track. Also, we have national analysis of marsh health and resilience. This is to understand where marshes are most vulnerable to sea level rise, or and then understanding the value of those marshes in reducing storm impacts helps guide restoration efforts. Again, this is work that's done nationally to inform large scale, for consistency over large scales, but it's informed by regional and local research that has been able to address specific systems and really understand the questions that locals have. Also thinking about the nature-based solutions, coastal blue carbon is an area where the administration is having us really focus right now. USGS researchers are looking to really explain the condition of coastal wetlands now and into the future based on how humans are interacting with the wetlands, as well as what sea level rise might come, looking at both the wetlands as sinks for carbon also, but how altered hydrology releases methane. Ultimately, these national maps are key to guiding the restoration sites and activities. The millions and millions and millions of dollars were given by Congress to a lot of groups to address coastal resilience and specifically restoration activities. And so the science helps to guide where to make those investments. Ultimately, right, the science that we're doing is intended to help people. It's science for service. And a big part of that is being able to translate, well, actually, we would say translate the science into risk. But that's the old way of thinking, because that assumes we're doing all of that work after the fact, after the science has been done. So to ensure that the work that we do better addresses the specific and unique challenges that people have, We're taking a much more active role in engaging with communities, particularly underserved communities that tend to have disproportionate impacts during storms and sea level rise. We're piloting projects to help identify the priorities, resources available to those communities, and really how best to work with them and the programs that they already have underway, or to initiate programs that would work within their towns. This picture is Rincon, Puerto Rico, 4 years after Hurricane Maria. I think Maria, that was 2017, and USGS. So as I showed earlier, USGS forecasts potential impacts of hurricanes days before the hurricane makes landfall. We do it for the Gulf and the Atlantic, but we did not for Puerto Rico. And when Hurricane Maria made landfall, we had nothing to tell them. And so after that storm made landfall, we got supplemental funding from Congress, disaster funding, to help address the coastal hazards problems in Puerto Rico. Part of that is being able to help with address long-term planning, and then also event scale or impacts to weather scale hazards. So here's so with that recent funding and a group that went into Puerto Rico to really work with the communities there to understand what they need, they developed a new model similar to the one we did before, where as a hurricane is making landfall, we are trying to predict which areas are going to be experience the most significant and destructive coastal change than the other areas. And this helps the emergency management officials really target where to go and have either evacuations or where to pre-position equipment to help with recovery. This is thinking about that. I'm going to pause that thought. Okay, pausing that thought. Okay, so here are the 3 color bands. Again, red is bad. It's telling you that there might be some erosion or some flooding due to that hurricane. Now, but throwing those models out there to the community isn't enough. Our job is scientific research to improve the information that's provided in those models. So there is so much research happening across USGS related to this, and I'm just picking out one pit here that helps, is part of this story. So following from producing those assessments for Puerto Rico related to coastal change during hurricanes, the team started to explore what was unique to Puerto Rico. This is a steeper shelf. There is a coral reef line, coastlines. The models that we had before didn't apply. So using a series of observations, wave buoys offshore, cameras to understand what waves are doing on the beach, how the beach is responding to those waves. And then also working specifically with communities like Torres Garcia, Mark Buckley, Kurt Storlazzi, and others have been working to provide more targeted information to help Puerto Ricans understand how their coast is responding to storms and sea level rise, and then do something about it. These slides are wonderful because Legna put them together, and she did this video, but she has been working, she's assigned a physical oceanographer who has been working really closely with the communities to understand what they know about hurricanes, what their questions are, and then provide the information they need. She is providing all of her information in Spanish so that it is more accessible and to lower barriers to access to information. This is a lesson that USGS Coastal is implementing across all of our science centers and related to the work that we're doing. I don't know if you've heard the expression of throwing science over a fence or something, over the wall, federal science. Targeted towards users. We make something great, or we think it's great, and here it is. well, that's kind of a waste of our time and doesn't help anybody. So being more thoughtful about engaging with audiences, with users, with the people who need the information. And we're using a transdisciplinary approach, which is a little bit different for what the Coastal Marine Program has done in the past, guided by social scientists who help us use a human-centered design approach to understand, to guide what we do through the eyes of the people who will be using the work. What we've learned so far, well, obviously their needs. People have questions and we have answers. We need to be able to connect it better with them, and we want them to use our science. However, their communities are completely overwhelmed. I think, just think of sea level rise, for example, and how NOAA, NASA, the Corps of Engineers, USGS, we all have sea level tools, and with little explanation of how they differ or which one anybody should use. We really, as federal organizations, have a responsibility to not confuse people, I think. We don't want to disrupt their lives or add clutter to already busy schedules that they have. So we really need to understand how they live their days, how they make decisions, and be able to deliver. We've done that. This is an exciting new thing for USGS. It's called the Coastal Science Navigator. It was created over about 3 years. It is an online resource that helps people find the coastal hazards information you need, whether it's data or a tool or a model. This was designed working with resource managers, emergency managers, who get really frustrated looking for USGS information. And so by a series of interviews with them and then evaluation of prototypes and working with them to evaluate and improve the site, we've created something that is pretty unique for USGS that helps guide people towards what they need and really provide consistent information on what USGS has to offer, whether it's the inputs that are driving this model, limitations you might expect, and uncertainties associated with it, and challenges when and where to use it. Okay. So, all right. So thinking more, the science that serves the public trust. They working with the public, they put their, hands, I don't know the word for it. I was going to say faith, but that's not it. We don't want faith in science, but because it's science and we prove it. But trust us to deliver information that is scientifically sound, and then we're going to go back and make it better. We'll see where we're wrong, where it doesn't apply, and find ways to improve it. So back to this total water level and coastal change forecast that is out nationally. The methods are aging. That was work that I did. It started with my PhD thesis, and so that's pretty old. It includes a parameterization for wave run-up that works on sandy beaches. The model, the parametric model, that is used to compare it to the beach elevation and predict what might happen is static. It doesn't account for the fact that the beach is moving during the storm, which we know it is. So USGS has some great young researchers. For example, Michael Itzkin, he's one of our postdocs, and he's working to improve the model that underlies this operational forecast in Coastal Change Viewer. This is the exciting work that he's done. He went out to Pea Island with a group of others to gather data on waves and currents, bathymetry, topography, measure what the waves are doing, how the beach is responding, and then comparing it back to the old model shown there on the left, and also other models that he's putting together some of the most exciting are these ensemble models that really can improve the accuracy of what we get out of these models. So that right there maybe is my, this is the exciting part. Personally, I'm excited by both of them, right? Because I love that the science that we do is getting out to the public and people are using it and depending on it. They're asking for it. And we're seeing where it's being used to help them make smarter decisions. And then also, because we're working with partners to help us get that information out, it really can steer our scientists back to the research that makes all of these models better. And so we've got a great crop of Mendenhall postdocs. I encourage students to consider USGS for your postdoc interests and come and work with the groups that are really targeting the research towards use. Okay, so we're gonna have to guess what is over there. Were all the slides like this? No. Okay, so here's my summary. These are just some things that this is very personal to me here at this point, or maybe the whole thing has been. Things that I think about a lot when I do this job, and a big part of it is trust. And so building relationships with people, knowing the public, knowing that we're listening to their concerns and we're learning together from each other and committed to providing information in a way that they will use it. And this is a sustained commitment too, not that we will help you with something and then leave you, but that sustained provision of information might depend on partners, such as NOAA, or working with FEMA and other partners who were really better equipped in that operational capacity or known to be that trusted provider during emergencies. Another thing I think about a lot is scope and diversity, and I relate to them. The US is big, and there are a lot of different environments and different processes at work. People are facing so many different kinds of problems. Also, different people with different interests, different concerns and things that they worry about, different limitations on what they're able to do or what they even have the focus to think about. We want to be able to work with local groups, with NGOs that are already attached to communities, or understanding communities' interests so that we can get this science to them. Responsiveness, so improving the capabilities for observations and modeling. This is so that the models we create don't get stagnant and stale and ultimately end up giving bad information, but also building that capacity for better delivery of information. I was just remembering someone's conversation today about all the data coming in from the visuals of collecting laser data and imagery, but we can get really overwhelmed by that. And so how do we stay on top of that capacity to deliver information, especially during emergencies? And then the complexity of this. The coastal environment is a lot of different sciences interacting together, and the recognition that we don't know it all, and so we need to work with other people to understand the system and really collaborate to find the answers that people need for working along the coastline and being able to continue to have economic health and safety and all of that. So that's where education comes in and collaborations with universities. That's it for me, and I went to the end. Before I give this up, I do want to say that we have a really strong marine program too. And I learned so much this morning about all of the work that you all do in the marine environment, and would love to expose you to some of that sometime. Not by me, by somebody else. But I think there's a lot of exciting work that, or collaborations that could happen in the marine environment as well. Anyway, now I'm out of breath. That's it. Any questions? Okay, Tom and then Kim online.
Thanks, Hilary, this is great, yeah. So I should comment that, I think that formula you were talking about, is that known as the Stockdon formula?
The Stockton
Yeah.
formula,
There's
yes.
about 2,000 citations on that paper, so it's pretty popular, yeah. So there's, is that Pound? Oh my
Yeah,
God, Peter
some
was
guy
a
named
co,
Pound
was a
before
junior
Bob
author on the paper, yeah. So lots of history here, yeah.
Oh, yeah, 2 authors of that thing in here.
So you have to implement the science that you have that the public consumes. And these models that we have are imperfect. And they have lots of parameterizations for them. And there's lots of public domain models out there that are being incrementally improved, which I'm sure you're collaborating with these groups. So how do you go about deciding that this stuff is ready for public consumption? Do you have to essentially go out and verify these models in places that you apply them? And do you spend time focusing on those particular areas? Or do you have particular gaps in your research that you're trying to further to improve those models through the parameters?
Both of those, yeah. So for example, with the total water level forecast and total water level coastal change forecast, the pieces of that model were implemented and tested in a variety of different locations, and both the total water level aspect and the coastal change part. And then to make that thing go operational with NOAA, we had to undergo testing with NOAA to prove a certain level of accuracy. And I'll tell you, when there's nothing already existing, it's not hard to be better than nothing. Okay? And this is not to devalue what we did, because it is providing information that people can use. So yes, so absolutely it needs to be tested and verified. And then they continue to test that model. So the total water level one, with coastal cams, working with universities and NOAA in targeted locations where they're collecting water level data and coastal change data. Okay, but more broadly than that, thinking about even just the marsh model or barrier islands under the influence of sea level rise and increased storms, it is making assumptions that you've got to be able to explain what they are, and then the implications, what that means, where you can be wrong, and being able to explain not just how you might be wrong, but the specific places where it doesn't apply or you should be more careful. And then in those places, working with local groups or universities who are really studying the details of a specific place or specific process and what's going on there. Sometimes there's this great expression that someone used for these national scale models that I need to recall, but it's almost like having that consistent approach to help you identify hotspots that then can guide where the future investments are, either in model development or restoration or preparations related to emergency management. I think a part of it is knowing what your expectations are and being really clear to communicate that, as well as limitations and confidence, which is a really hard thing to get out there.
So we have 2 questions online. We want to go with Kim first and then Martin Wozniak next.
You mentioned that this is the flip side of what Tom asked. You mentioned that your methods are aging, and that's understandable, but I'm curious, what sort of provisions do you make for having events that are so extreme, so extreme that potentially a model breaks? And I'm under some of the most extreme climate change scenarios, for example. I don't know, you might get something where you're trying to take the log of a negative number or something that was completely unforeseen, so that effectively you get to a point where things are so extreme that your models or tools break. How robust are your models? Are you trying to build robustness in them so that even though they're aging and they will need to be updated, that you won't necessarily have to do a complete overhaul?
Wow, that question kind of blew my mind. I think, well, we haven't encountered that. And when I think about the models that we're using at national coverage, at kind of a local community scale, the models and the inputs to these models, I don't think they won't allow for that to happen. For example, the inputs to the total water level model come from NOAA. And so what feeds it is the nearshore wave prediction system, which is the NOAA approved system that comes from, I believe, WaveWatch 3 and SDOFs. So these are tested, verified, often used models that are providing the input and driving what we're doing. For the work that is based on future climates, again, we lean on the work of others in those identifying future climate scenarios or rates of sea level rise, so that we are leaning on their expertise and pulling it into what ours is, which is specifically that interaction of the coastline with landscapes and beaches, communities, that type of thing. I don't know if that answered your question or if it felt like I was going around it.
Oh, no, I think that's fine. It's just something that, those of us who work in this field, of course, we recognize sometimes things break despite your best effort, and what you're doing, your answer to the public. And so it's a different perspective. So no, that's great. Thank you very much.
Yeah, I think certainly they break, and certainly models will explode and show something that's not possible. But responsibility putting these things out nationally, if people are using them, that they won't do that. And so there are almost so many simplifications that's not possible.
Yeah, understood. Thank you.
Martin, go ahead.
Yeah, hi Hilary, can you hear me okay?
Yes.
Great, yeah. So thank you very much for traveling to UNH and sharing all this information with us, sharing your work with us. It's great. So you highlighted that USGS, as many of us are too, is struggling to communicate the information you want your, broadly speaking, stakeholders to reach. So for the results for your models, I guess many people care about the very, very, very short term, as in what will happen with the storm that's coming up the coast in the next few days. But they also should be concerned about what's happening in 20, 50 or 80 years, however long they would like to look ahead. So I was wondering, there's the struggle between, or the struggle to strike a balance between making scientific results easily understandable, and on the other hand, making them complex enough or yet complex enough to capture the full story. Could you describe what this discussion looks like at USGS to try to strike this balance between keeping things simple enough to understand, yet complex enough to be meaningful?
So it was a little bit hard to hear you. Is your question about how to work with the public and explain the complexities of hazards that could happen now this week and also in 30 years? Or is it about the models specifically?
Not so much about the model specifically. It is more about, you mentioned you started working with social scientists to help you communicate to the public what these results mean, and so could you comment maybe on the discussion at USGS about this balance between making results simple enough to understand, yet having enough complexity in them to really be meaningful and telling the full story, if you will?
Yes. Yeah, that is a big problem, and we even see that with hurricanes. So, for example, a hurricane will pass through and a community is destroyed, and then, or maybe not destroyed. Let's make it a less extreme example. It really devastates their town. Life is hard for a few months, then they get back on their feet and forget that that ever happened. That a hurricane could do that to their coastline. And so, getting people to visualize or imagine what their lives would be like in future climates is a really hard thing to do. And that is partly why we use storm events, so the impact of storm events, to help provide that visual or point to how their lives might be affected in future climates. So thinking about a small storm, some storm surge, elevates water levels, moves the waves a bit higher on the beaches. The waves are hitting places where they normally don't. Can give a community an idea of what it will be like when water levels are higher, or even to be able to show them the difference between what happens during a storm that happens at high tide versus low tide. So here's an example. I live in St. Petersburg, Florida. Hurricane Idalia came towards us this year, and it was looking like a direct hit, but it went further north in the Panhandle. And because of the way the storm winds circulate, winds blew up into Tampa Bay and flooded a lot of the neighborhoods that people weren't prepared for it at all. They couldn't believe that they were had impacts from this hurricane. Well, the weathermen, why do we call them weathermen? What do we call them? People, weather announcers, meteorologists. They went out in the neighborhoods and reminded those homeowners that, well, your house floods, your streets a couple times a year because of king tides, and started to help them draw these connections between what they were seeing now, small changes due to rising sea levels, and then how the impacts of storms are affecting them more, or the occurrence of problems in their lives. It's happening more frequently, that they can't get to work because their road is flooded. What we have learned, and of course this is such a small thing, we are just starting to learn this. But is that being able to connect personally with things in people's lives and what affects them. But again, that's hard because so many, what is our lifetime, and what are we worried about, 20 years or 30 years? And really it's the future of the earth, and that's like Friday. So you've asked a great question, and it's a thing that I'm really happy that USGS has decided to hire social scientists as researchers, which is a really new thing, and it's really exciting. They are the most popular people in USGS right now. Yes.
Yeah, thanks for that explanation and answer. So back to your comment, how far can people really think ahead? I don't think people do think ahead more than maybe 2 or 3 generations. So it's really hard to, if they do it all. But since you brought up weather people, another quick comment, and not a question, is that I've heard multiple people say on the news they always exaggerate how bad storms are going to be, because weather people, I guess, want to err on the safe side. And that sort of also, I think, erodes trust if they're told by some outlet that things are going to be very bad, and then they're not. Then it's not as bad because the storm missed by a little bit or something. So anyway, just a comment. Yeah, thanks again.
And one other additional response to you is, yes, people have a hard time thinking 20, 30, 40 years in the future. And that's why we depend, on having some leaders within the communities who can help translate, sound the alarms, okay, that sounds alarmist, I shouldn't say that. Convince them that this is worth caring about and thinking about, and there are things you can do that can help. Okay, question here.
In a world where it's so easy to take pieces of information like out of context and take visuals without their like original background, how do you strike a balance between like having a model simple enough to convey like the information you want clearly while still providing the public with all of the information that you want them to know?
Yeah, I'm almost gonna challenge your question there, because I think, so when you talk to people about the information they want, users, you know, they're deciding to build some nuclear power plant. You know, what do you want? What do you need to know? And they say, we want everything. We want all the science you have, every piece of it. Well, that's not right. They don't want that. And so it's coming at this question from two ways: understanding the questions that they have, understanding the science, and really what information is needed, because they don't need everything. And sometimes it is that most simple explanation that is the right one. I like your question. It makes me think, you know, this thing we keep telling ourselves, a responsibility to not confuse. And so just being really clear about what you can expect a model to tell you and what it can't be used for and what it's not including. And that's hard. You know, it's easy for me to say that because people will read into it or make other assumptions that probably don't apply. So, you know, communication is such a big part of all the science that we do. Being really good communicators.
We have one question online that I'll just ask really quickly, and then I know we're over time, so after that, if folks want to stick around, you're welcome to, but no pressure. So Alyssa online asks, the USGS model coverage that you showed in several of your slides does not address the large coastlines along the Great Lakes. There's significantly less risks from hurricanes, but as you mentioned, there are other coastal hazards. Can you comment on the Great Lakes Coastal Resiliency Study and how this will impact some of the tools or products in the Great Lakes region that USGS might provide in the future?
That's very, very observant. I can't comment on that study specifically, but we are building coastal hazards programs in the Great Lakes right now. So that total water level and coastal change model, a postdoc is working to implement that in the Great Lakes. Again, that's an opportunity. It's a different type of processes. So how do you take that general framework for the model and insert the right hydrodynamics for lakes and the way the impacts to the lakeshore, and who are the users there, what are their questions? So this is going to be a very unsatisfying answer to you, except to know that we are working in the Great Lakes now with some of those organizations that I don't remember that acronym. But that was a great observation, and we are not forgetting the Great Lakes.
Let's thank our speaker again.